We are Team Can Do, and this is our Sprint 1 presentation.
Hi, my name is Octavianino. I'm a development team member.
My name is Brady Menswar, and I'm the Scrum Master.
And my name is Jared Sanders. I'm the product manager.
So for our update here after Sprint 1, we have completed our functioning backend for our web application. We set up our database to make sure that we could use our CRUD APIs to access everything and update our tasks, comments, and users. And now that we're done, we're ready to move on towards our front end and making sure that the end user can have the functionality they need to connect with the database. Started this sprint off making our software tests. Here you can see the layout of one of our tests below. These tests are run through Postman, so we have our API endpoints set up, and we use different HTTP requests to gather information from our database and change things. Here you can see our GET request. We had 29 tests in total, and we've run through most of them already with a lot of success. Here you can see our get all tasks working in Postman. With the endpoint, we send it to get all, and you can see it returns all of the different tasks that have been uploaded into our database and returns a 200 status code, meaning that everything worked just how we intended.
All right, yeah. So as far as the functionality, technical progress, and backlog accomplishments, we pretty much split that into functionality being what it does, technical progress being how it does it, and then the backlog accomplishments basically what was done to get there. So starting off with the functionality, basically we've designed the tasks API to be able to, or basically we follow the CRUD functionality. So create, read, update, and delete. So we can create tasks and upload them or insert them into a DynamoDB table. And DynamoDB is a service offered in the Amazon Web Services, so AWS. It's a NoSQL table. It's extremely quick. And, we wanted to, performance was one of our main priorities. So we chose DynamoDB. So we can read from the table. We can create, update, and delete in that table. We also follow CRUD for comments. So we can create an individual comment, and then we can also update and delete comments. So as far as the technical progress, we've got our serverless. So we use serverless to deploy into AWS. Serverless is a backend framework that basically it's a CloudFormation template framework. So basically it just creates the templates that, so we can deploy into AWS multiple times, and it also lets us share amongst the team so we can all deploy and get the same code and the same results. So the screenshot on the left is the serverless.yaml file, and this is just an example of how we set up some of our functions. As you can see, we have the get task, and create task in the screenshot. It's just what we could fit. So we have a handler, so it points to the handler.typescript file, and it points to functions inside that handler file. And also we set up the roles, so it allows the API gateway to access, or API gateway in Lambda to access that specific DynamoDB table. And then we also set up our HTTP API paths for get methods, and at the bottom for create task, you can also see the post method. So on the right, you can see a sample of our handler TypeScript file. Just the top part of the create task function, where you can see that we get the body of the request and we call it data. And we use a task interface using TypeScript. So that lets us validate it as we compile the code. And then we also validate the body using a testing framework called, or a validation framework called Joy. So we can basically validate that data before it's even processed. And if it's missing any required fields or anything like that, we return a 400 and we provide the error. And then at the bottom there, you can see some of the results from the serverless deploy, where we have a very random looking URL, but you can see it follows a CRUD kind of style with a couple GET requests, POST request, a patch, and a delete. So as far as backend accomplishments, what was done to do it, a quick screenshot of our done and in review. And this is basically just a summary of our sprint 1, and we'll go over sprint 2 in a little while. But basically we wrote up all the schemas for tasks, comments, and users. We developed this test to enforce the schemas up front, and we used the Joy package to validate that, so we could make sure that the code that we wrote followed the schemas that we had already written. And then after we wrote the business level requirements, like the schemas and the table requirements, stuff like that, we started configuring the API, configuring API gateway and writing the Lambda functions to handle the requests and send the appropriate response.
All right, and this is a bird side of our Kanban board right now. As you can see on the right, we have everything relating to sprint number 1. We have most of the stuff done. Some things are still in review, but we have already moved the stuff related to sprint 2 out of the backlog and into the to-do and in progress swim lanes. Now we focus on what the sprint 2 will be. We still have some configuration and review related to the tests, as we could also see on the last slide, but we're looking forward to everything that has to do with the front end mostly. We're estimating that will take between 38 and 54 hours. And finally, we consider what we're going to be doing for sprint 2. As I said last time, we still have to tie up some loose ends in the back end, make sure everything runs smoothly, and then we can move on to the front end, the UI, the user experience, write some other plugins to finalize tying that up, and so we can have something, a performing product to showcase in our next presentation. We also consider that this is the end of the semester and there will be other things coming up that might put a constraint on how much time we can spend, but we're excited to get everything up and ready so that we can deliver a good product.
Thank you for your time.